Draw a circle of radius 1, pick a point on the circumference, draw the radius, allow that radius to rotate round to an angle of 30 degrees. Drop the perpendicular, complete the triangle. What is the length x? In the previous video, we were trying to find this height here, which was opposite the angle. But now we're trying to find this length here, which is adjacent to the angle. So we have the adjacent here, and we have the hypotenuse. The cosine function is given by the ratio of the adjacent divided by the hypotenuse. Make sure your calculator is in degrees. We'll put in the cosine of our angle, which is 30 degrees. And this gives us the answer 0.866. Draw the vertical diameter, shift it to the right. Our cosine function is given by the adjacent divided by the hypotenuse, which is x divided by 1, which is just the value of x. So the height of our cosine function, which we shall draw here, is just going to be the height x. So we'll shift the x across to represent the height. This length here can be shifted over to the correct angle on our axis. So let's return this to 0 degrees. We will put on a trace, and you'll notice the trace will map out the first 30 degrees of the cosine function. And we know from our calculator that the height of the cosine function at 30 degrees is given by 0.866, which is simply the length x. We can write this mathematically as x upon r is equal to cos theta. We can rearrange this as x equals r cos theta. We can put our values in for our r, which is the hypotenuse, which is a value of 1, and the angle 30 degrees. And from the calculator, this gives us the result x is equal to 0.866, which is just this length here. Let's look at these 4 examples here. In the first example, we have a right angle triangle. The length that is opposite the right angle is always the hypotenuse, and it is of length 6. The given angle is 27 degrees, and we're looking to find the length x. Now, the length x is adjacent to this angle. This other length here, you can see, is opposite the angle. So we have the adjacent and the hypotenuse. The adjacent divided by the hypotenuse is the cosine function. So we can say then that the value of x divided by 6 is equal to the cosine of our angle, which is 27 degrees. And we can rewrite this as x is equal to 6 cosine 27 degrees. So if you put into your calculator 6 cosine 27 degrees, and remember to keep your calculator in degrees, then we'll get the length x. So let's have a look at the second one. Again, we have a right angle triangle. The length opposite the right angle is the hypotenuse, which is a length 7. We have the given angle 34 degrees, and we're asked to find the length x. Again, the length x is adjacent to this angle 34 degrees. And you note here that this other length here would be opposite the 34 degrees. So if we're given the adjacent and the hypotenuse, then we can use the cosine function. So again, we can write the value of x divided by 7 is equal to the cosine of 34 degrees. So we can rewrite this as x is equal to 7 cos 34 degrees. Again, you can put that into your calculator, 7 cos 34 degrees, and it'll give you the value of the length x. Now let's look at the third example. In this example, again, we have the right angle here. The length opposite the right angle is the hypotenuse. We've got the given angle, which is 19 degrees, and we're asked to find this length x. Now in this example, the length x is the opposite. So we're given the opposite and the hypotenuse. So if we divide the opposite divided by the hypotenuse, then we could use the sine function in order to work out what this length is. But in these examples, we're actually going to be using the cosine. So in order to use a cosine, what we're going to do is we're wanting to find the angle which is adjacent. So the angle that is adjacent is going to be 180 minus the 90 minus the 19, which is a value of 71 degrees. Now we didn't need to go through this process. We could have just used the sine function and worked it out that way. But let's go ahead and we'll do it using the cosine. So now we can look at this, we can say that the length x divided by the value 9 is the cosine function, and it is equal to the cos of the angle 71 degrees. So again, we can write that as x equals 9 cos 71 degrees, and that will give you the value for the length x. But of course, as I mentioned, we could use the sine function. In this case here, we could write the value of x divided by 9 is equal to the sine of 19 degrees, because x is opposite this value of 19. So finally, look at this one here. We have a right angle triangle, we have a length of 4, we have an angle of 17. X is adjacent to that angle, so again we're going to have the value of x divided by 4, which is the adjacent divided by the hypotenuse, which is equal to the cosine of the angle 17 degrees. So the value is x is equal to 4 cos 17 degrees. And you can put this in your calculator and get the value for this length x. So let's work through the 4 examples in the calculator. The first one is 6 cos 27, which will give you a value of 5.346. The next one is 7 cos of 34, which will give you a value of 5.8. Now the third one is 9 cos 71, which gives a value of 2.93. But of course, we're able to work out the third one also using the sine. So let's have a look and see, and we should again get the same answer, 2.93. So this would be 9 times the sine of 19, and again it gives the value 2.93. So the final one is 4 times the cosine of 17 will give you a value 3.825.